Racks, of course, come in all shapes, sizes, and weights. It's very important to note where the center of gravity is on the particular unit that you're working with. The center of gravity, when talking about a large, let's call it a 42U type unit, about 84 inches tall, if that center of gravity sits above the halfway point, the unit becomes extremely unstable and should be treated very delicately. That's also determinative of the footprint that you need to pass a 22-degree tip test. So when that center of gravity is low, you may only need a 34-inch footprint on that unit. If that center of gravity is much higher, you may go all the way up to a 42, sometimes even a 48-inch footprint to pass that tip test, depending upon the stability of that particular unit. It is very important to understand not only the overall size and weight of the unit, but where the center of gravity sits in that vertical axis. The low clearance between the bottom of the rack mount unit and the floor itself can be as small as 3/8 of an inch sometimes. When that happens, it becomes quite the challenge to get it up onto a base in order to ship it. What we found is the best way to accomplish this task is with a steel ramp lip. It's about the only way you can support that much weight and still get a solid surface that won't crack. Any attempts at plywood with a rack over about 500 pounds are going to result in failure and could very well result in a tipped rack. When you do a steel ramp lip, it's also important to make sure that that thickness is welded across the front edge so that the 1/16 of an inch that you need in order to actually grab the unit and guide it up that ramp stays that consistent size and doesn't get warped or bent. You'll see a lot of units out there with warped or bent steel that was improper gauged or not welded correctly. Large cabinets with casters and leveler pads are generally not designed for loads during shipment. If a 1,000-pound cabinet has 500-pound capacity wheels and it sees 3 Gs in transit, that 1,000-pound cabinet just became 3,000 pounds, and those casters are likely to fail during impact. It's times like those when you need to take into account what G load you're expecting and what the caster rating is. You may need to put some material underneath of that cabinet to support the casters, to help them along the way if they do have an impact. Internal vibration can be one of the biggest problems when packing a rack. When you see the exterior of a rack and it looks nice and solid, it looks great when you go to pack it. When you open up that rack and you start looking at some of the bolts and some of the way that these rack mounted units have been secured, you'll find that they're not quite tight. And during vibration in transit, those will all start to rattle loose. And once one thing gets loose, it builds on itself. So it's very important that you look at the interior of the rack that you're packing. It's also very important that the cables are not loose, because those cables bopping against each other during transit will create a lot of exterior vibration as well on rack-mounted units. So it's very important to look at the internals of the rack that you're shipping, as well as the external panels and other configurations that may be mounted to the unit itself. Feel free to leave any comments or questions, and thank you for watching.